Hi all, today we are going to discuss conduction of lead network experiment. Now as you can see the circuit diagram, in this is the function generator and this is its CRO channel 1 and capacitor and resistor, where CRO channel 2 you can see. Now let us see the practical components. The first one is function generator here, then capacitor, then resistor, then this is a CRO which is having channel 1 as well as channel 2. Now let us see the circuit connection one more time. See here, from function generator two wires are coming here. That is, one is red in color and another one is black in color. Then CRO channel 1 is again having two terminals, that is red in color and black in color. Then capacitor is having two terminals, terminal 1, terminal 2, and resistor is also having two terminals, terminal 1, terminal 2, as well as CRO channel 2 also having two terminals, red and black. Now while we are connecting this circuit, you have to make sure that in lead network the first component is capacitor and the second component is resistor, and one more thing, where we are collecting the output, that is very matter. Now output we are collecting always at the second component. So let us start the connection now. See here, in order to connect the function generator to the R and C components here, we will use probes here. See, each probe is having two terminals, red in color and black in color. Now in our circuit, we are connecting the function generator to the CRO channel 1 first. So function generator is having two terminals, red and black. So function generator red and CRO red we are connecting, and function generator black and CRO black, channel 1 black, we are connecting together. That connection we are making now. Now see here, I am connecting the probe to the function generator which is having two terminals. Now I am connecting CRO channel 1. From here again two terminals are coming. Those two terminals are coming, and those colors you can able to see here. So it is having red and black and it is having red and black. Now I am connecting the red to red and the black to black. That is the connection which is shown in the circuit diagram. Now from here, this red, just try to remember this red is always should be connected to the first component of the circuit. So here the first component of circuit is capacitance. Then these two blacks must be connected to second component of the circuit, that is nothing but resistor. So this connection you have to make very clearly. Right? So we have to connect here in such a way the reds of two terminals, two things must be connected to first terminal of the capacitor, then blacks must be connected to second terminal of the second component. After this, the next connection we will see here. The next connection is the capacitor second terminal must be connected to resistor first terminal. So we will make this connection with the help of patch card. So we will take one patch card now. Now we are connecting according to our circuit. The second terminal of capacitor should be connected to first terminal of resistor. So this connection is made. Then the leftover connection is the output connection in the circuit diagram. See here, the output connection here make the CRO channel 2 red terminal should be connected to first terminal of resistor. Then CRO channel 2 black terminal should be connected to second terminal of the resistor. That we are making now. Now we are connecting this connection now. So I am connecting the probe to the CRO channel 2. So here we are connecting the probe to the CRO channel 2. From here again two terminals will be coming, terminal red and terminal black. Now see, in our circuit diagram, the terminal red is connected to the terminal 1 of resistor and black is connected to the terminal 2 of the resistor, that we are making. So here red we are connecting to the terminal 1 of the resistor Then graph we are connecting to the terminal 2 of the resistor. This connection we are making. By this the connection is done. Now we need to conduct the experiment. Now in the circuit diagram it is very clearly mentioned the input for the circuit is 4 volt peak to peak with 1 kilohertz supply. So this we have to keep by using the function generator. So we are setting this input by using the function generator. So I am turning on the experimental kit. See, the function generator is turned on. Now in this function generator you can able to see few notches here. One is frequency notch, then function notch, modulation, attenuation and menu. In this mainly we will focus on these two terminals, that is frequency and function. Suppose if you want to keep the frequency not 1 kilohertz, if you want to keep 10 kilohertz, then you have to click on the frequency button. But our requirement is to have 1 kilohertz, that's why I am setting it 1 kilohertz. See, now it is 100. If I click again, it will go to 1k. So it is showing 1k. Suppose instead of 1k, if it shows different value, see here, now it is showing 349. So how to keep this one 1 kilohertz? If you ask question, see here, variable notch is there, frequency variable notch. So you have to adjust this one and you have to set 1 kilohertz here. So frequency we kept now 1 kilohertz. Now we have to set the amplitude. We have to set the amplitude of the waveform, that is 4 volt peak to peak. For that we need to study about the CRO. So coming to here CRO, I will be turning on the CRO, but before that, see, you can observe here square boxes in the CRO. Each square box represent 1 unit. Each square box represent 1 unit. 1 unit is divided into 5 parts. So each division is 0.2. Now here each unit value will be displayed here by using voltage knob. This voltage knob indicates each unit voltage. Each unit voltage. Now see here this voltage knob is indicating 1. That means here each unit value is 1 volt. Now if you keep this one at 2, then each unit value is 2. So that is the setting of CRO. So our convenience, we are keeping this one at 1. When CRO channel 1 is kept at 1, then CRO channel 2 also you have to keep it at 1 only. So you should be very careful when you are conducting this. So both the channel voltages must be same. So this is about CRO. Then before turning on the CRO, each knob should be a released one. It should not be a pressed one like this. So it should be a released one. That you need to take care. Now I am turning on. Once the CRO is turned on, see, you can see the input waveform. You can see the input waveform. Now again here waveform is what kind? Sinusoidal type. So we have to set sinusoidal type. Now I am telling here each unit is called 1 volt. Now we need to set 4 volt peak to peak. So here you can see this is positive peak, this is a negative peak. Now the voltage must be 4 volts total from here to here, means the positive peak should be 2 and negative peak should be 2. That we have to set. But before that, one more thing you have to take care. This waveform is aligned properly or not, we have to take. For that I am pressing the ground button. When I press the ground button, it became a straight line. Here you can able to see here this is a Y shifter and this is a X shifter. Now by using these two, we have to align this waveform properly. So make sure that this line coincides with the X axis. That is the proper alignment. Then release the ground button. Now I can see it is aligned properly. Now I have already said that it is now, you can see it is covering 2 units in positive and 2 units in negative side. So total 4 units is covering. So 4 into 1, 4 volts. That is nothing but 4 volt peak to peak. Now we have set the input. So 1 kilohertz frequency is given, 4 volt peak to peak is given. Now the very important thing, we need to observe the output waveform. For that you see here X5, XY and channel 1, channel 2, then mono or stop is there. See, mono means single. So if you want to see two waveforms, you have to press this mono. When you press this mono, automatically you can see two waveforms here. But again here, the second waveform is properly aligned or not, we need to check. So how to check it? See, in the channel 2, again you press the ground button. Now the channel 2 waveform will come. It became a straight line, and this channel 2 waveform is properly aligned. You can see this is perfectly aligned with the x-axis. Now I am releasing this ground button of channel 2. Now you can see here two waveforms. So anything you take as a reference. Now I am taking as a reference here. Now in this, the small waveform is output and the large waveform is the input. Now you can able to see here the small waveform is starting first, which means the small waveform is leading, whereas the large waveform is lagging. Now according to our experiment, if output leads the input, then we will call it as a lead network. See here output is leading the input. So our experiment is conducted perfectly. Now one more thing what we need to calculate, we need to calculate the phase angle difference between the output and the input. That is nothing but phi value. As we have already know, phi how to calculate means by using Lissaj's circle. Lissaj's circle is nothing but the combination of x and y components of input and output. So you need to mix x component of input and y components of output. That is called Lissaj's circle. Sir, how to get Lissaj's circle? See here in this CR2, you can be able to see this XY button. Now if you, what is this meaning XY button? It is a mixing of x and y components of input and output. So press this XY button, then you can be able to see here one straight line. But actually we need to get this circle here. So release the XY button, again press it. Now you can be able to see one circle. This is called the Lissaj's circle. Now this circle is aligned properly or not, we need to check again. For that you need to press the ground buttons of channel 1, then ground buttons of channel 2, so that it will become a dot. Now make sure this dot should coincide at the origin. For that we will use here Y shifter as well as X shifter, and we will make sure that it coincides at the center. Once it coincides at the center, release the ground button of channel 1, then release the ground button of channel 2. Now from this Lissaj's circle, we need to measure V1 and Vm values. Vm is represents the maximum point of the Lissaj's circle. See here, the maximum point of the Lissaj's circle is indicating 2 units. So its value is 2 volt. So we will write down, we have to write down the maximum point of the Lissaj's circle is having 2 units. 2 units is nothing but 2 volts. Then V1 we need to get. So V1 how to get? See here, from here where it touches the y-axis. From here where it touches the y-axis means where it intersects the y-axis, that will give you V1 value. That we need to measure. How to measure? See, this is covering 1 unit here. After 1 unit 1.2, then 1.4. So V1 is 1.4, whereas Vm is 2 volts. So these two things we need to enter into our tabular column. Then we can find the value of phase angle difference. So this is the way of conducting the lead network experiment.